Hello everyone, in this lecture we will discuss the equilibrium constant, equilibrium concentration, equilibrium relation between the reactant and product. We will discuss a problem related to the equilibrium concentration of reactant and product and equilibrium, also the equilibrium constant. Now there is a problem related to the equilibrium constant. For example, the carbon monoxide react with water gaseous state and it form carbon monoxide gas react with water gases and it form carbon dioxide gas plus hydrogen gas. Now initially the concentration of carbon monoxide and water was, suppose we have 1 liter container and we put 0.1 mole CO and 0.1 mole water, 0.1 mole H2O, 1 mole. Similarly, we put 0.1 mole of CO. At the start, we put 0.1 mole CO and 0.1 mole of water into the container. After a certain time, the reaction occurred and the product was produced, which is CO2 and hydrogen. We measured the equilibrium constant for this reaction, which was 23.2. It's 600 Kelvin. Remember that the equilibrium constant is depend on the temperature. So at 600 Kelvin, the equilibrium constant was 23.2. Now there is a question that what will be the equilibrium concentration of the CO2, hydrogen and water and carbon monoxide. So this will be obtained from the ICE table, which show the initial concentration, the change in the concentration and the equilibrium concentration. So there is a nice ICE table, which is I, initial concentration, change and the equilibrium concentration. And these are the reactants, carbon monoxide and water. Initially the carbon monoxide was 0.1, it was 0.1 molar. 0.1 molar. The water was 0.1 molar. 1 molar. What was the concentration of CO at the start? There was no CO2 at the start in the container. Similarly, at the start of the reaction, there was no hydrogen in the container. Similarly, at the start of the reaction, there was no carbon dioxide in the container, so their concentration is 0. This is the concentration of hydrogen was 0. Now, when 1 mole of carbon monoxide reacts with 1 mole of water, 1 mole of carbon dioxide and 1 mole of hydrogen is produced. Similarly, when 1 mole of carbon dioxide and 1 mole of hydrogen react, again it will form 1 mole of water, 1 mole of the carbon monoxide. These are the stoichiometric coefficient 1, 1, 1, 1. So when 1 mole of, now what will be the change? These are the initial concentration. What will be the change? When 1 mole carbon monoxide decrease, then 1 mole of water will also decrease. So when X mole of carbon monoxide decrease, then X mole of water will also decrease. And at the same time, when 1 mole of carbon monoxide decrease, 1 mole of carbon dioxide will be increased. When 1 mole of carbon monoxide decreased, 1 mole of hydrogen will increase. So this is the change in the concentration of reactant and product. Now when the initial and the change in concentration when combined, it will form the equilibrium concentration. Now combine, add these two row, we will get the equilibrium concentration row. So 0.1 minus x, 0.1 minus x, 0 plus x, 0 plus x. This is the equilibrium concentration of carbon monoxide. Equilibrium concentration. This is the equilibrium concentration of water. Water equilibrium concentration. This is the carbon dioxide equilibrium concentration, and this is the hydrogen concentration of the equilibrium. Now what will is the rate constant is given to us at 600 Kelvin. Now what will be the equilibrium concentration? What will be the equilibrium concentration? What will be the equilibrium? The equilibrium constant is denoted by concentration of the product is the product of the concentration of product at equilibrium divided by the product of the concentration of reactant at equilibrium. So the equilibrium constant was given to us, which was 23.2 at 600 Kelvin. Now the equilibrium concentration of carbon dioxide was x. It was 0 plus x. It was increased, which was x. Similarly, the water hydrogen was 0 plus x, so it is x. So x multiplied by x, it is x square divided by the carbon monoxide equilibrium concentration. So it was like 0.1 minus x. It was equilibrium concentration of carbon monoxide, and 0.1 minus x was the equilibrium concentration for the for the water. 0.1 minus x for carbon monoxide and 0.1 minus for water. So 0.1 minus x, 0.1 minus x. Again we can simplify this relation to find the equilibrium concentration of carbon dioxide and hydrogen, and when we will get the equilibrium concentration for carbon dioxide and hydrogen. So the equilibrium constant was given 23.2, and the equilibrium concentration for carbon dioxide was x, and for hydrogen was also x, and for carbon monoxide it was 0.1 minus x, 0.1 minus x, 0.1 minus x. This power and this power, when combined, it will square x square, 0.1 minus x, 1 plus 1, it is 2. Take the square on both sides. On both sides we will get the equilibrium concentration for carbon dioxide and hydrogen, for the equilibrium concentration of carbon dioxide and hydrogen. Equilibrium concentration. Now suppose it is some value like y. Suppose it is y. Now what will be the equilibrium concentration for carbon monoxide? As we determined the x, which was supposed the x was y. Now put this value in this relation, 0.1 minus y, which is equal to the equilibrium concentration of carbon monoxide. Similarly, 0.1 minus y is the equilibrium concentration of water. This y can be 0.01, 0.02. That is, can be some value that can be determined from your calculation. Thanks.